I get a sinus bug. Yeah, I get sick twice a year. What did you do? Three hits, All right, today we're going to talk about triangle proofs. We have 5 different ways to prove triangle congruency: side, 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 angle, side, angle, side, angle, 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 side, hypotenuse, leg. What information about 2 triangles allows you to conclude the triangles are congruent? We are going to try and apply our theorem to construct triangles and to solve problems. We're proving triangle congruency using our theorems. Down here we have triangle rigidity, including angles and included side. Okay. All right. First off, the property of triangle rigidity basically states this. If the side lengths of a triangle are given, triangle can have only one shape. If you think about it, this particular definition makes sense. Put it in context. If I tell you to go create a triangle with side lengths of 10 inches, 12 inches, 15 inches, the only thing you can make is a 10-inch, 12-inch, 15-inch triangle. That's it. If you know the side lengths, you know precisely the shape that you're dealing with. All right. First theorem or postulate that we're going to talk about today is the side congruence postulate. Okay. If 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. So their example, AB is 4 centimeters, DF is 4 centimeters, BC is 6 centimeters, DE is 6 centimeters, AC is 7 centimeters, EF is 7 centimeters. I've got 1, 2, 3 sides that are congruent in 2 different triangles. Therefore, I can go ahead and conclude side that those 2 triangles are congruent. No, that's right over here. Right? Here we go. I don't think we have to write this down. We already have this one defined in our notes. We'll go over it again. An included angle is an angle formed by 2 adjacent sides of a polygon. Okay? Angle B is included here between sides AB and BC. Think about it. These sides, AB and CB, form that particular angle, so we call that the included angle. Not that bad. Let's talk. What would be the included angle between sides BC and AC? Yes. No. BC and AC with the included angle. What? C. BC and AC, angle C. BA and CA. What's the included angle? A. Okay. An angle is between or formed by those particular sides. Right? This gets us to our next postulate, which we call the side angle side congruent postulate. If 2 sides in the included angle of one triangle are congruent to the 2 sides in the included angle of another triangle, then the triangles are congruent. Again, their example here, BA and CA are congruent to FE and DE. Okay, so that's 2 side lengths, but I add with it the included angles of A and E. Those angles are congruent side lengths that make them are congruent to each other. The two triangles are congruent. That is what my conclusion is. My conclusion is that the triangles are congruent. Moving on. Okay, included sides. Sometimes this is difficult for people to see. An included side is the common side of two consecutive angles in a polygon. Okay. For whatever reason, we don't always. For whatever reason, it's difficult to see this sometimes. But side PQ is included between angle P and Q. That side is included between those two angles. Okay? Since that side is included between those two angles, well, it's going to help us out whenever we get to our next theorem. All right, angle side angle congruence postulate.
I love you. Good luck.
If two angles and the included side of one triangle are congruent to the two angles and the included side of another triangle, the triangles are congruent. So we have side angle side with an included angle, and then we have angle side angle with an included side. You order something. Okay. All right. So look at their example. You'll see that side AC is between angles A and C. Side BF is between angles D and F. If two of the angles are congruent and the included side is congruent as well, in two different triangles, that means that the triangles are congruent. Well, if the non-included side is congruent in two different triangles, you also have congruent triangles. So, two angles, we call this the angle side congruence theorem. Two angles and a non-included side of one triangle are congruent to the corresponding angles and non-included side of another triangle. I have triangle congruency. Side, 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 angle, side, angle, side, angle, 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 side. Okay. Yes, they have to match up. Yes, it has to be in order. This example, HJ and LM are not included between the congruent angles. Okay. But nonetheless, we can still conclude that the two triangles are congruent, provided that the two pairs of angles are congruent and the non-included sides are congruent as well. Okay, good news is we only got one left. Okay, we call this last one hypotenuse leg. The hypotenuse leg congruence theorem states if the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and the leg of another right triangle, then the triangles are congruent. What types of triangles does it have to be? It has to be a right triangle, okay? The longest side of a right triangle is called the hypotenuse. Hypotenuse is always opposite the 90-degree angle or across from the 90-degree angle. Okay? The other two sides that are not called the hypotenuse. They are called the legs of a right triangle. The right triangles have two legs and a hypotenuse. And if on two different triangles, the hypotenuses and one pair of legs are congruent, then I can conclude that the two triangles are congruent.
Anyone else doing funky slides today?
Hopefully everybody's got that down now. Let's remember, determine if you can use angle side angle to prove that triangles are congruent. Please explain why. Types of problems that we do today, okay? With angle side angle, just based on the information I've been given here, would that work? You say yes, I say why, how? Okay, well, I'm given two angles, but what do I need for angle side? Side, which side? It's not a right triangle, so I don't know about legs or hypotenuse. Now, what do we call the side? If it's between two angles, call it an included side. Very good. Very good. So check it out. I do not have enough information right now. Do I have anything that tells me that those two sides are congruent? No. No, I don't. I do not have any information that tells me that the included sides are congruent. I cannot conclude that angle side angle is congruent. I do have information, though, that I could use. I would use a different theorem. Maybe angle side. Are these sides congruent? Yeah. You know that through the reflexive property, correct? Okay. So now look what I have. Angle side. Angle side. So can I use angle side angle? No, sir. So can I use angle side? Yes. Okay. Tomorrow we'll learn a really important, maybe one of the most important theorems that we have. It's called CPCTC. Corresponding parts of the congruent triangle are congruent. Corresponding parts of the congruent triangle are congruent. Corresponding parts of congruent triangle are congruent. What that does for me is, once I prove triangle congruency, once I use side, angle, side, hypotenuse leg, once I get that the two triangles are congruent, I can use CPCTC to tell me that the other corresponding angles and sides are congruent as well. So that's where we're ending up with all this. Okay? All right? What about right here? Do I have side, and then these two triangles? Yes? Or no? Okay? Do I have side here? Yes. Noel, you say yes. Why do you say yes? Okay? Well, I want you to not just say you kind of know, but think through here, okay? As it stands right now, how many tick marks do I have? How many pairs of them? 2. But something's going off in your brain that says what? Wait a minute. That last side of the triangle. This side, BC. BC in this triangle have to be the same as BC in that triangle. Yeah. ABC, BC has to be the same as DBC, that BC. Okay? I use this example in first block. Some kids are like, oh, that makes sense. Let's say you got a pizza. This is the reflexive property kind of in a nutshell. Okay? get my pizza, check it out. Y'all see this side right here, blue side? Let's call this slice 2 and this slice 3. Is the blue side going to be the same in slice 2 as it is in slice 3? Same measurement. Yeah, right? You cut your pizza up, okay? You cut your pizza up into slices, right? If you think about it, I'm guaranteed, the only thing I know for certain is that the blue side in 2 is going to be the same as the blue side in 3. It has to be the same, okay? It's 2 different sides cut along the same measurement, right? It's the reflexive property in a nutshell. How about here? Can I use side angle side to prove that triangle ABC is congruent to BBC? Yes. What theorem? I've only got. Let's make sure. Is it this? Check it out. Is it side angle side? No, it's not. What is it? It's AB, angle B, and then side BC again. What property? I'll say it back to me. What property helps me conclude, or the reflexive property helps me conclude that BC is congruent in both triangle ABC and in triangle DBC. Okay? Yes, this reflexive property is now going to become really important to us, right? All of a sudden, I got to use the reflexive property over and over again. That would to help me out when I do these congruency triangles. Okay. All right. Now let's see if we understand this a little bit more. Angle B. Look at angle B. Okay. In DBC, this triangle, you see how angle B is included between sides BB and CD? We'll say that included language. Okay. What included means between those 2 sides. This is where we're going. This is what we want to be able to do. This type of proof is what we want to be able to do and complete on our own without Mr. Hans telling me. Okay? All right, so I'm given that QP, ray QP, bisects angle RQS. I'm also given that QR is congruent to QS. I'm trying to prove the triangle RQP is congruent to triangle SQP. Let's use that given information and add what I can conclude. I've said this over and over again throughout this course. Hopefully you're picking up on it now. An angle bisector divides a large angle into 2 congruent angles. Okay? So RQS, angle RQS, the big RQS, big angle. If QP is the angle bisector, that means it divides it into 2 smaller congruent angles. Okay? Now, through another property, a reflexive property, I can conclude that QP is the same in both of those triangles. So which theorem would I use here? Side, angle, side. Side, angle, side. Okay? Any questions on that? That's what we want to be able to get to. That's what we want to be able to do as we're doing these theorems. Okay? Last one here. Right? It says determine if you could use hypotenuse leg congruence theorem to prove that the triangle is congruent. Okay, can you? Yes or no? Okay. All right, so first off, what is the hypotenuse? It's the longest side. It is opposite of my right angle. Okay? It is opposite or across from my right angle. Over here, I would go ahead and draw my box. Do I have hypotenuse here? Yeah, these two hypotenuses are congruent. So then I gotta look for legs that could be congruent. Okay? What's gonna be congruent? The base legs or the vertical legs? For what property? Reflexive property. Now, hopefully it's starting to make sense to people. Okay? The reflexive property. Now all of a sudden I've got hypotenuse and legs congruent. So I can use my HL, my hypotenuse leg theorem, to prove triangle congruent.